Welcome to The Explainer. Today, we're going deep. We're diving beneath the surface of the artificial intelligence you use every single day to uncover the massive hidden reality that powers the whole thing. I mean, it really does seem like magic, doesn't it? You type in a question, and out comes a coherent, creative answer. But behind what looks so simple is a level of complexity that, honestly, stumps scientists for decades. For the longest time, researchers would build these huge expert systems with just these dizzying lists of if-then statements. But if you think about it, language is just messy. It's full of exceptions and nuance, and that old approach was always a step behind. The real breakthrough? It came when we stopped trying to manually code every single step, and instead we let the machine figure it out for itself. Okay, so let's dive into this. How does an AI actually think? Well, the answer lies in this incredibly powerful architecture that completely changed the game. It's called a transformer. To make this super simple, we're going to use a fantastic analogy. I want you to imagine a line of people, and each person is holding up a single word from a sentence. Now, this is not a one-and-done kind of thing. It happens in layers. Think of it like a detective story unfolding, just one word at a time. With every single round of questions and answers, the people in that line get more and more context, and their guesses about what's coming next become unbelievably accurate. Okay, so what's really cool is how this whole analogy maps back to the AI. Those attention heads you see on the screen, that's basically the questions being shouted. It's the mechanism that lets the AI focus on different parts of the sentence to pick up clues. And the MLP, well, that's like each person's individual brain power, their own internal memory they tap into to make sense of the answers. It's this beautiful combination of communication and internal thinking layered over and over and over again that lets the AI build such a rich contextual understanding of language. Look, having a powerful mind just isn't enough. It also needs to be safe, and it needs to be aligned with our values. A brilliant but rogue AI is, well, that's not what anyone wants. So how do you do that? I mean, you can't just feed it the entire internet with all the good, the bad, and the truly ugly stuff and just cross your fingers and hope for the best. That is an absolute recipe for disaster. This is where a really special training technique comes into play. RLHF. Think of it as basically a guidance counselor for the AI. It's a way of teaching the model not just what the right words are, but what the right behavior is, based on what we as humans actually prefer. So the crucial point here is that we're actively rewarding the AI for making responses that we humans find helpful and safe. First, it learns by example, kind of like a student studying from a perfect answer key. Then it learns from our rankings, and it starts to develop a sense of judgment. And finally, it practices on its own, just trying to get better and better at hitting that high score for good behavior. And right here, this is where the hidden part of that iceberg really starts to emerge. All of this software, all this thinking and learning, it requires a truly astonishing amount of physical hardware. So what does that machine actually look like? We're moving now from the abstract world of software to the colossal world of physical hardware. And the numbers here, they are genuinely staggering. $2.5 trillion. And let's be super clear, that is not the total cost over a decade. According to the research from Gartner, this is the forecast for total worldwide AI spending in the year 2026 alone. Just 1 year. And this table just perfectly illustrates the scale. Just look at that top number. AI infrastructure, we're talking the physical servers, the data centers, the chips, that accounts for over half the total cost. It is a literal gold rush for hardware right now. So to meet this incredible demand, we're seeing projects on a scale we have just never witnessed before. Project Stargate is a jaw-dropping $100 billion plus investment to build a network of advanced AI data centers. This is, for all intents and purposes, the foundation for whatever comes next, a massive bet that the future of AI is going to require more power than we can currently even imagine. And look who's building it. This is a coalition of titans. You have OpenAI setting the technical direction, Microsoft and Oracle providing the massive cloud backbone, and of course, NVIDIA supplying those all-important GPUs. This isn't just a project, it's a strategic alliance, with every single company betting big on a future that demands unprecedented computing power. But the financial cost is only one part of the story. There's another, more elemental cost that we rarely talk about: energy.
875 times. A recent study compared the energy needed for a human versus an AI to do the exact same complex 3D modeling task. The result? The human was 875 times more energy efficient. Let's just visualize that for a second. It's not even a competition. The human brain, which has evolved over millions of years, is an incredibly optimized machine. For a focused task, it just sips energy, while the AI, it absolutely guzzles it.
And to put that into perspective, that is enough energy to run a standard light bulb for over 21 million hours. And just remember, that's for one model of one airport.
And this right here is the bottom line. AI is incredibly fast, for sure, but it is not always smart or cheap. If the design needs multiple revisions, and let's be honest, most complex projects do, the immense energy and computing costs of AI can very quickly make it more expensive than just hiring a person. So the next time you use an AI, just remember that vast, hidden iceberg of capital and infrastructure and pure energy sitting just beneath the surface. The magic we see on our screens, well, it's powered by a very real and very resource-intensive world. Thanks for watching.